Come on guys, let's check out Kubernetes architecture today. This is the architecture of Kubernetes. We have two planes here. One is control plane, another one is data plane or node plane. First, let's check out the control plane. Control plane is like boss in Kubernetes. It makes all the big decisions, like where to run the applications and what to do if something goes wrong. We have four components in control plane: Kube API server, scheduler, controller manager, and etcd. Let's check out each of these components in detail now. Kube API server is like front desk or receptionist that handles all the requests. So Kube API server is the only way to interact with the Kubernetes. So user talk to API server using the REST APIs. So you can use kubectl or any other tool to send a request to Kube API server. So that request can be creating a pod or some other requests. So then API server will check whether that request is valid or not, like you have the correct permission or not. So once the correct permission is there, then it informs the other components of the Kubernetes. So in short, Kube API server is like a receptionist. It coordinates everything while ensuring all the rules are followed. Then the second component is scheduler. Scheduler is responsible for deciding where to run the applications. Here scheduler is like a smart matchmaker. It will ensure that each pod finds the best worker node to run. Let's see how the scheduler works. So first step is pod creation. When you create a pod, it doesn't immediately know where to run. Second step is scheduler steps in. So scheduler looks at the pod's resource needs, constraints, and the labels. Third step is scheduler evaluate the nodes. So it checks all the available nodes in the cluster and filter out those that don't meet the pod's resource needs and have the rules or taints that the pod can't tolerate. The fourth step is scheduler scores nodes. Among the suitable nodes, it assigns the scores based on available resources, node affinity or anti-affinity, and network proximity. The final step is assigning the node. So the scheduler selects the best scoring node and it also updates the pod specification. Like this pod is bind to this particular node. So here scheduler is very important to balance the load. So load balancing is very important feature of scheduler. So in short, scheduler is smart matchmaker. So it ensures every pod will get the best possible home. So next component is controller manager. So controller manager is like a multitasking supervisor. It ensures that every task in the cluster is running fine. Actually, the control manager will constantly watches the system and fixes the issues, and it ensures that the desired state is matches the actual state. Actually, control manager will manage the different controllers. Here each controller looks after a specific resources like pods, nodes or services or etc. For example, controller like node controller, it monitors the health of the worker nodes and takes action if a node goes offline. Similarly, replication controller, so it ensures that the correct number of pod replicas are running. Similarly, there are other controllers, and control manager will manage all these controllers. So first function of control manager is it manages all the controllers. And the next function will be the automation. So it will automate routine tasks like scaling the pods, restarting the failed pods, or cleaning up completed jobs. All of this will be automated by the controller manager. So this is how the control manager works. First, it will watches the cluster. So it continuously monitors the cluster state using the API server. Then it compares states and it will check if the actual state matches the desired state specified in your configurations. Your configuration will be like deployment files or any other files. And third step will be it will take the action. So if there is a difference between actual state and desired state, it will take the action to fix that. So if a node fails, the node controller will remove it from the cluster. And if a pod is missing, the replication controller will create a new pod. So in short, control manager is a multitasking supervisor. It is like behind the scene hero of the Kubernetes. The next component is etcd. This is like a brain of your cluster. So etcd is a distributed and it is a key value store. It keeps all the critical data needed for managing the cluster. It is like database for your cluster and it stores the data in key value format. So now let's see how it works. So first step is it is a central database. Means etcd stores the desired state and actual state of your cluster. Here desired state means what you want and the actual state means what is happening, and etcd stores both of these states. The second step is interaction through Kube API server. Here the Kube API server is the only component that communicates directly with the etcd, and other components like scheduler or control manager interacts with this etcd via the API server. Then the actual function updates and reads. So when you create or modify the resources, the Kube API server updates the data in the etcd key value store. Then anytime scheduler, control manager and other components reads data from this etcd store and it will ensure the cluster operates as desired. So here etcd is the single source of truth. So without this, Kubernetes wouldn't know the state of the cluster. So it is responsible for storing all the important data about the cluster, and without etcd, the cluster simply wouldn't function. So those are the component of control plane. So next see the data plane or worker node plane. These nodes will take the order from the control plane and do the actual work of running your application. And here each node will have three main components: kubelet, container runtime, and kubeproxy. Let's check out each of these components now. First component will be kubelet. So kubelet will run on every worker node in the cluster, and its main job is to ensure all the containers in the nodes are running and functioning as expected. We can call it kubelet as an agent that runs on every node of the Kubernetes cluster. Let's see how it works. So first step is receive pod specs. The kube API server will send the pod specs to the kubelet. So these pod specs will describe what containers need to run and their configurations. Second step is schedule pods locally. So the kubelet ensures the specified containers are running on the node by working with the container runtime. The third step is monitoring the containers. So the kubelet will continuously check the health and status of the containers, and if a container crashes, the kubelet will restart the container. The fourth step is sends the status updates. Kubelet will report the health and status of the both node and pods back to the control plane. So kubelet is very important component, and without the kubelet, Kubernetes couldn't manage workloads on the individual nodes. The next component is container runtime. So container runtime is responsible for managing the containers in the node. Let's check out this in detail now. So container runtime will work under the kubelet to pull the container images, start the containers, and manage their lifecycle. Actually, container runtime is a software, and that will handle the low-level task of running the containers. Let's see the key responsibilities of container runtime. First one is pulling the container images. So it downloads the container images from container registries like Docker Hub, Nexus, or AWS ECR. Second one is starting and running containers. So container runtime will launch us the containers using the pulled images, and it will ensure that they run as specified. Third one is managing container lifecycle. So it handles the container creation, starting, stopping, restarting, and removal of the containers. Fourth one is resource isolation. So it ensures the containers get the right CPU, memory, and storage without interfering with the other containers in the nodes. One is networking. So it will set up the networking for the containers. It will allow the container to communicate within the cluster and also externally. The last one is reporting status. So container runtime reports the status of the container to the kubelet. Then kubelet will send the update to the control plane. There are many container runtime softwares. The most popular is Docker. Other container runtimes are Containerd, Creo, Runc, and Podman. So in short, container runtime is the engine that runs containers in Kubernetes. The last component is kubeproxy. It is a network component that runs on each node of the cluster. So it is responsible for managing the network traffic, and it will ensure that pods can communicate with each other and with the external clients also. Let's see the key responsibilities of kubeproxy. First one is service networking. The kubeproxy will help to implement Kubernetes services by managing the network rules that route traffic to the appropriate pods. Also, it ensures that traffic is directed to a service is load balanced across the healthy pods. The second one is traffic route. So kubeproxy listens for the changes in the Kubernetes API server, and it will adjust the node's network rules accordingly. Also, it routes the incoming traffic from external clients or other pods to the right pods. Next is pod-to-pod communication. So it enables the seamless communication between the pods running on different nodes in the cluster. Fourth one is service discovery. So kubeproxy works with the DNS add-on, and it ensures that services can be accessed by their DNS names. So in short, kubeproxy is the traffic manager in Kubernetes, and it will ensure the smooth communication within and outside the cluster. So that's it. This is the architecture of Kubernetes. We have two planes, control plane and data plane. In control plane, we have kube API server, scheduler, control manager, and etcd. And in every node, we have kubelet, container runtime, and the kubeproxy. Hi guys, today we're going to create our first Kubernetes deployment. So let's do that now. So for Kubernetes deployment, I'm going to use AWS EKS today. You can use any other cloud service like Azure and GCP also, but I'm going to use AWS EKS for now. So there are some prerequisites. So prerequisites like first, obviously you need a AWS account. Then you have to install AWS CLI on your laptop. So you can install AWS CLI. Then you can log into your AWS account using that CLI. So you can run AWS configure, and you can add your secret and other things, and you can log into AWS account. So if you have any questions or any trouble while logging into the AWS via CLI, then you can check out my AWS CLI video also. Then then you have to install kubectl to run kubectl commands and interact with the cluster. You need a kubectl tool, so install that. Then also I'm going to use EKS commands. So for that, you have to install EKSCTL also. That is a CLI for EKS. So all of these are prerequisites. So configure all of this, and if you face any issues while configuring this, you can add that in comment. I will help you on that also. So let's start. So first what we need is an infrastructure. Infrastructure is nothing but a cluster. So we need a cluster first. We can create a cluster from the AWS management console also, but I'm going to use EKSCTL command. So let's create the cluster now using EKSCTL. I can copy paste the command, but I'm not going to do that. I'm going to type the whole command now. So first EKSCTL, that is the tool. Then I'm going to create the cluster. So create cluster. Then I have to give a name for this cluster. So hyphen name, that is the flag. Then the cluster name, I can give any name, like I will give my cluster or any name. Then in AWS, I have to give the region, which region I want to spin up this cluster. So I'm going to spin up this in Mumbai region, so AP South one. Then in cluster, I have to give a something called as node group. Node group means group of our nodes. Means nodes here are nothing but EC2 instances. So group of worker nodes, basically these are. So hyphen node group. Then node group name. Node group name can be my node group name. So give. Then I have to give a node type. Node type is nothing but EC2 instance type. That can be anything like T3 dot micro, T3 dot medium, something like that. So I'm going to use T3 dot medium. So hyphen node type T3 dot medium. Then the number of nodes I need. So hyphen nodes. I'm going to spin up two nodes now. So hyphen nodes two. And then for auto scaling, I can mention minimum and maximum number of nodes. So nodes hyphen min, I can set it to one. Then hyphen nodes max, that can be 3 or 4. So that is a maximum number of instances for auto scaling. Then I'm going to add one more flag, that is hyphen managed. Here managed means this node group will be managed by AWS. So the health check of this particular node group, everything will be managed by AWS. And if you remove this flag, then it will be the self-managed node group. That's it. Let's run this now. So it should create a cluster now. So it will take 10 to 15 minutes generally. So let's wait for that. It will create our both the plane, like control plane and data plane, that I've explained in Kubernetes architecture video. That is the previous video. You can check out that. So first it will create a control plane. You can see here it will create a control plane for my cluster. Then it will create a data plane like a node group and everything. It will create like a node group is nothing but the group of your EC2 instances. It will take 10 minutes. So let's wait for that now. So now the cluster is created. You can see that my cluster in the AP South 1 region is ready. So now I can run a command called as eksctl get cluster. You can see cluster is created. Name is my cluster and region is AP South 1, and it is created using eksctl. Also, you can check that cluster in your console also. So it took 10 to 15 minutes to create the cluster. That is because it create lot of resources. It create whole infrastructure. That's why it took that much time. So in backend, it uses CloudFormation templates. If I go to CloudFormation resource in AWS, I will get two CloudFormation templates are created. One is for my EKCTL, my cluster for whole cluster, and another one is for my node group. That is for worker nodes. So if I open my cluster CloudFormation template, and if I check resources here you can see these many resources are created. So to create all of these resources, it took 10 to 15 minutes. So it create NAT gateway, internet gateway. In backend, it will create all of these resources. If I run that tkctl create cluster command, it will create all of these resources now. Then if I check one more stack, that is my ng, that is for node group. Here it has launch template and managed node group and node instance role. All of these resources it created. So if I go to EC2 now, it should create two nodes. So if I go to, because number of nodes we have mentioned two. So if I go to instances, here you can see there are two nodes are created. That is my ng node. So now the cluster is created. To interact with the cluster, generally we use kubectl command. So before using kubectl command, we have to configure that kubectl command to interact to have the access of my cluster. So to configure kubectl, I can run command aws eks, then hyphen region, that is AP South 1, AP South 1. Then I can I can update the config file, that is kubeconfig file, update hyphen kubeconfig, then the name of my cluster, that's hyphen name, then my cluster name is my cluster. So it will create a new entry in my kubeconfig file, and that will have the details of my cluster now. And if I see my this kubeconfig file now, cat, I will give this in double quotes, and this file path. If I paste this here, I should get the details of my new cluster, that is my cluster. So this new entry is added to my kubeconfig file. Now I can interact with the my cluster using kubectl. Now let's run kubectl command. So I will clear this. For example, I will run kubectl get nodes. So it will list all my nodes now. Nodes of this particular cluster. I have not mentioned any cluster name here, but it lists the nodes of my cluster because in kubeconfig file I have had the entry of my cluster name. So now my cluster is ready and nodes are created. So next step will be the creating or deploying the application using kubectl. For that I have to create a YAML file for the deployment. So I'm going to create a file called as nginx deployment dot YAML file. Now I can copy paste the whole YAML file, but for a better understanding, I'm going to write the YAML file now in this particular video. So first in this deployment Kubernetes YAML file, I have four main contents here like AKMS. A means API version, K means kind, M means metadata, and S means spec. So just remember that. So first is A means API version. No need to remember this, but if you write multiple YAML files, then you will get to know this like API version, kind, metadata, and spec. So first is API version apps slash v1. This is the API version. Then will be the kind. Kind is deployment here. So we are going to create a deployment resource here. So here kind nothing but what type of Kubernetes resource we are going to deploy. So here the resource will be the deployment. So Kubernetes deployment, there are other kind also like services and other things. So, but now I'm going to create a deployment. That's why kind will be the deployment. Then AKM, M means metadata. Metadata is nothing but to identify this particular resource, that is this particular deployment now. So metadata will be, I can give a name for this like name. Then the this is the nginx deployment. That's why I'm going to give a name as nginx. Then last will be the spec. Spec means specifications. So specification. So in specification we mention like how many number of pods we need. Those things we are going to mention here. So number of pods we are going to write replicas here. So replicas I need two pods now. So replicas will be two. The selectors, as the name says, it helps us to select the specific pods for this particular deployment. So we select the pods based on the labels. So for that we have an entry called as match labels. Then we have to add a label using key value, like key will be the app, then value will be the nginx. So we select the pods which has the label app nginx for this particular deployment. So all the pods of this particular deployment will have the this particular label, that is app nginx. So in spec we have the entry replicas, then the selector. So next entry will be the template. So template will be for the pod. This is pod template or pod blueprint. So each pods of this particular deployment will have the specification mentioned in this particular template. In this template, first entry will be the metadata. Here, this metadata is for whole deployment, but this metadata is for particular pod. All the specification mentioned inside template will be the pods, not for the deployment. So metadata, the metadata will be labels. I can have a label for each of the pod. So each pod should have this particular label, that is app nginx. That I'm going to add here, app nginx. So that is for metadata. Then have to add the spec for this all of this particular pods. So inside spec we generally mention the container specification. Pod is nothing but containers, right? So container specification I'm going to mention in this particular spec. Here spec first entry will be the containers. Containers. So inside the container first entry will be the name for the container. Name of the container, that is nginx. Then container should have the image, right? So docker image, that is image. I'm going to use nginx latest image, nginx hyphen latest. So it will pull from the docker hub. This is the public image, so there is no issue for pulling this nginx latest official image. So it will pull that image to create the Nginx container. The next will be the ports. Here I'm going to mention the container port. So container port I'm going to use is 80 port. So Nginx will run on 80 container port. Remember the extra tab here, that tab is not required, that is the index. So this is the YAML file. Let's save this now. Escape colon WQ. So YAML file is created. Now let's create a deployment. For that I have the command kubectl apply. Then the -f is the file for file name, and the file name will be nginx deployment YAML. So now the deployment is created. So I can run kubectl get deployment. So kubectl get deployments. Then in replicas I have mentioned S2. That means two pods should be created. So let's check that. For that I can run kubectl get pods. So two pods are there, but status will be the error imageable. So there is some issue with my YAML file. Let's fix that first. Let me delete this deployment first. For that I can run kubectl delete deployment, then the deployment name, that is nginx. The deployment is deleted now. Fix the my deployment YAML file. Here you can see in image I have mentioned nginx hyphen latest. That is not the way, like I have to give the colon here. So nginx colon latest. Here the image name and the tag will be the latest. Then this is the typo mistake. So let's save this file. Again create the deployment now. For that I can run kubectl apply -f, then the file name, that is nginx deployment file. Then kubectl get deployments. So deployment is created now. Again, if I want to see the pods now, kubectl get pods. Now you can see status is running. So now my deployment is created and my pods are running. But how to check whether my Nginx application is running or not? How to access my Nginx application from my browser? For that I have to expose this particular deployment. For that I have the command kubectl expose. So let's run expose command kubectl expose my deployment. Deployment is Nginx. Then the port -f port I want to expose it to 80 only, and the target port, that is the my container port, target port, that will be also 80 because container port is 80. Then the type of this particular expose is nothing but a service that keeps Kubernetes service and other things I am going to explain in next videos. So now it will be the external load balancer I am going to use. So type of this particular service is load balancer. Here you can see service engines is exposed. Now I can run kubectl get services. Here you can see Nginx service is created, and I should be able to access this application using this particular URL, and the port will be 80 only, and there will be another port 32,460. This is the node port IP. So don't worry about this. I will explain this later, and also don't worry about this service and other things and load balancer. All of this I'm going to explain in next videos. But to expose this particular deployment, I can run kubectl expose command. Then I will get this particular external IP or external host name. Using this host name, I should be able to access my application from my browser. So it will take some 1 or 2 minutes to expose this particular URL. So wait for a couple of minutes, then you can copy and paste this in your browser, and you should be able to access the Nginx. Let's paste this URL and let's see whether it is accessible from my browser or not. It is accessible now. So using kubectl service, I can expose my deployment to internet also. So we successfully deployed my Nginx application, and we are able to access from browser also. So let's see how to delete this cluster now. To delete the cluster, I have the command called as eks delete cluster, then the hyphen name and the cluster name, that is I think my cluster, right? So my cluster. Then I can mention the region also. Region is AP South 1. So that's it. You can enter that. So it will start deleting my cluster. So it will take again 5-10 minutes to delete this cluster because it have to delete all of those resources. So that's it for today. Today we learned how to create the cluster, then how to interact with that cluster using kubectl. Then we created a YAML file and we successfully created a kubectl deployment. That is the end goal of this particular video. Then we also learned how to expose my deployment to the internet. Come on guys, let's learn how to manage pods in Kubernetes today. So pod is the smallest unit in Kubernetes deployment. Let's see how we can manage those pods in Kubernetes today. So I have already created the cluster using ekctl create command. So this is what I have explained in previous video. So let's create pod now. So generally we create pod using deployment or a replica set, but today I'm going to create pod with kubectl run command. So the command will be kubectl run, then the pod name. I am going to create nginx pod today. So nginx hyphen pod, then the image. So it need a nginx image. So image equal to nginx. I can give a command called as or flag called as restart equal to never. If I run this now, so now the nginx pod is created. So here we have added the flag called as restart equal to never. This is because in case of deployment, if we kill a pod, a new pod will be created because it should match the desired state. But here now I am creating a standalone pod. That's why restart equal to never. If I kill a pod now, the pod is gone. It won't create a new pod. Then I can run a command kubectl get pods. So one pod is there, nginx pod, and the status is running. So kubectl get pods will give only the status and the name of the pod. But if I want more details, then I can run kubectl describe pod and the pod name, that is nginx hyphen pod. So it will describe all the pod details like service account, node, start time, status, IP address, and all the container details like container ID and the image it is used, and the port, host port, and everything. So if you need any details about the pod, you can run a command called as kubectl describe pod. And if you face some error related to the pod and if you are troubleshooting, then logs will help. So kubectl logs command will give the logs about the pod. So kubectl logs, then the pod name, that is nginx pod. So you can see the logs of this particular pod, like launching the container and the entry point. Those all the details we will get in the pod logs. So all the events related to the pod will be captured here. Then like deployment, I can expose the single pod also. For that, I can just run the command kubectl expose pod and the pod name, that is nginx hyphen pod. Then I have to give the port. Port is obviously 80 and the target port, target hyphen port, that is also 80. Then I have to give the type. Type is nothing but the service type. In previous video, I have created a load balancer service. Today I am going to create another service called as node port. So kubectl expose is nothing but creating a new service. So I will explain about the service and various type of services in the next videos. In this video, I'm just showing the how we can expose the pod. So new service is created now. Now I can run command called as kubectl get service. Here I can see the nginx pod service and the type is node port, and I have the port details like 80 and the 30,671 will be the my node port. Then I should be able to access this pod using the external IP colon and the node port, that is 30,671. So now instead of creating a single pod, let's create a replica set. So this will maintain multiple replicas of this nginx pod. Let's create a YAML file vi nginx replica set .yaml. If I enter this now, so let's add the YAML content here. So in previous video, we have written this YAML file from scratch. So in this video, I will brief this YAML file once. So we have four main contents here, that is AKMS, API version, kind, metadata, and spec. API version is apps/v1, it's always apps/v1 only. So kind is the Kubernetes resource which we are going to create. In previous video, I have created deployment, that's why kind is deployment. Now I am going to create a replica set, so kind is replica set. In metadata, I just given the name for this particular resource, that is this particular replica set will be called as nginx-rs. In spec, we will give the specification of this particular replica set, that is nginx-rs. So replicas will be 3, means number of pods will be 3. Then how we can select the pod for this particular replica set, that we have mentioned in selector using the labels. The label will be app nginx. Then the pod template. This will be applicable to all the pods of this particular replica set. Here in metadata, I have added the label that will be the same label, that is app nginx. Then the pod specifications. Here mainly we will provide the details about the container specifications. Here container name will be nginx and the image we are going to use is nginx colon latest, means the image is nginx and the tag will be the latest. And the port we are going to use this container port, that is 80. Now let's save this file using escape colon wq. Now let's apply this YAML file using kubectl apply, then the file name -f and the file name, that is nginx replica set. So this will just create a replica set, and if I run now kubectl get pods, ls missed. This is the standalone pod I have created earlier, and these three are the pods created now using the replica set. Here now we have three replicas that are running, and now if one of the pod is stopped or if it is failed, so Kubernetes will automatically get a new pod. This is to maintain the desired count. Actually, let's do that now using kubectl delete pod, and I can delete this pod now. So pod is deleted now, and if I run again kubectl get pods, you can see in replica set still we have the three pods. Even if I delete one pod, there will be one new pod will be created, that is this one. You can see 7 seconds ago it is created. This is because in YAML file we have mentioned replicas as 3. Now let's delete this standalone pod. Let's see what will happen. So kubectl delete pod nginx pod. So the pod is deleted now. If I run again kubectl get pods, that standalone pod is gone now and it will not be recreated. So that is the difference between the standalone pod and replica set. Now I want to modify this particular replica set YAML file, and I will make replicas as 2. Then I will save this file. Before running apply, I will just make sure that 3 pods are there. Here you can see 3 pods are running now. Now if I run kubectl apply after modifying the file, you can see replica set is configured now. First time it will show it is created. Now it is configured. Means it is updated. If I run again kubectl get pods, now you can see the only 2 pods are running because in replicas I have mentioned as 2. So it removed 1 pod because it should match the desired count mentioned in the YAML file. Similarly, if I modify this particular YAML file and if I make replicas as 4 now, now again apply this particular YAML file. Now if I run kubectl get pods, here you can see there are 4 pods. These 2 are the newly created pods. Kubernetes main job is to match the desired count of the pods. So that's it about the pods. You can delete this particular replica set using kubectl delete replica set or rs, then the replica set name, that is nginx rs. Replica set is deleted now. If I run kubectl get pods now, you can see there are no pods because replica set is deleted now. Similarly, you can delete the service also using kubectl delete service nginx pod, I think. So service also get deleted now. So that's it for today. We have learned about the pod management today. So I will delete my cluster now. And hi guys, today we're going to learn scaling and rolling update of Kubernetes deployment. So let's start that now. So first create a deployment. So for that I can create a deployment YAML file first. So va deployment.yaml. Then I have added the content for this particular deployment. So in previous session I have explained this YAML file. Today I will just brief this. So here we have 4 main contents, that is AKMS, API version, kind, metadata and spec. API version is always app/v1. Then kind is type of the Kubernetes resource you are going to create. Today I am going to create a deployment. Then as a metadata you can add name for this particular deployment, that's nginx deployment. Then you can add specifications. So here replicas is nothing but number of pods in this particular deployment, that is 3. How you can select the pods for this particular deployment, that is using the selector. So we use labels for selecting the pods, and the label key is app and the value is the nginx. Then we add pod template for this particular YAML file. Then all pods should have the labels called as app nginx. And this is the pod specification. Generally we specify the container specification here. And the container name is nginx, and image we use is nginx latest, and the port, that is container port. So nginx will run on 80 port. So let's save this particular YAML file. Then let's create the deployment using kubectl apply -f. F means file name, then the file name, that is deployment.yaml. So L is missed. So now nginx deployment is created. You can run commands like kubectl get deployments. So you can see nginx deployment is created and it has 3 pods. Also deployments will have the replica sets. In the YAML file we have mentioned the replica as 3. So we can run command like kubectl get replica set. So we'll get this particular replica set now. So when we create the deployment, indirectly we are creating the replica set also. Here replica set is nothing but group of standalone pods. So now let's see the scaling part. So let's check manual scaling first, then we will go for the auto scaling. For scaling we have the command kubectl scale deployment. So we are going to scale the deployment. and the deployment name, that is nginx hyphen deployment, then hyphen hyphen replicas. I'm going to scale it to 5. Here scaling is nothing but increasing or decreasing the number of pods, means number of replicas. That's why I'm going to add this particular flag now. So when I run kubernetes scale command, internally Kubernetes will schedule the new pods. If I run kubectl get pods now, you can see 5 pods are running now. So using Kubernetes scale command, I can scale my deployment. Similarly, I can reduce the number of replicas. For example, I am going to give it 2. So now internally Kubernetes will terminate the additional pods. Now if I run kubectl get pods, we have only 2 pods now. So this is one method of scaling. Also, I can modify the deployment YAML file. Then I can run kubectl apply. So I will modify the replicas as 4. And if I save this file and if I again run kubectl get pods, I have only 2 pods now. And now if I run kubectl apply, deployment is configured means deployment is updated now. And if I run kubectl get pods now, I have 4 pods. So there are two ways in manual scaling. One is using kubectl scale command. Another one is directly mentioning the YAML file and apply that particular YAML file. Now let's see the auto scaling part. There are many types of auto scaling. First, we will check the horizontal pod auto scaler. So for horizontal pod auto scaler or for HPA, I can run the command called as kubectl auto scale, then the deployment, then the deployment name, that is nginx hyphen deployment. Then I have to add a matrix here. Matrix is nothing but based on what auto scaling should happen. Matrix like CPU percentage, memory percentage, something like that. Here I am going to use hyphen hyphen CPU percent, and CPU percentage I am going to add it as 50%. Then I have to provide minimum and maximum number of pods. So minimum I can give 2, and hyphen hyphen maximum I can give 10. You can see horizontal pod autoscaler is created now. So when I run this command, if the CPU percentage is greater than 50%, Kubernetes will automatically scale up the number of pods. And it will scale up to the 10 pods because maximum pods is 10. Similarly, if the CPU percentage is less than 50%, Kubernetes will scale down the number of pods. It will scale down up to 2 pods because minimum number of pods is 2. You can get the HPA status using kubectl get HPA also. HPA is nothing but horizontal pods autoscale. Here you can see the details like the name of the autoscaler, then the reference, then the targets, then the minimum number of pods and maximum number of pods, then the replicas. Replicas here is 4. And autoscaling target is CPU percentage, that is 50%. So HPA details you can get using the command get HPA command. So this is HPA, horizontal pod autoscaler. Similarly, we have VPA, means vertical pod autoscaler. In HPA, we are going to increase the number of pods, and vertical means we are going to increase the resource of particular pods. For VPA, we can create separate YAML file, vpa.yaml. Here I have added the YAML file content. It will have AKMS. EPA version is different now. And the kind is a Kubernetes resource, that is VPA. In metadata, I have added the name of this particular VPA, that is nginx VPA. In spec, I have mentioned the target reference. Here target is nothing but the deployment, that is nginx deployment. And I have added the update policy, that is update mode auto. Here in update mode, we have 3 choices. I can have a value of. Off means VPA only recommends the values, but it does not apply those values. Another choice is initial. When I mention initial here, VPA sets request only when the pod is created, and it won't update the resources while running the pods. And another choice is auto. Auto means it will automatically update the pod resources even when the pod is running. Here auto mode is dangerous because this will apply to the running pods also, and it might recreate the pods. This might result in a downtime of your application. Let's save this YAML file now. So that is about different auto scaling methods. We have HPA and VPA. Now let's check out the rolling updates in Kubernetes deployment. So here update means you are going to deploy the new version of your application. So now let's check out those application updates using the Kubernetes deployment. And one note here is during the update there should be no downtime. This can be achieved using the Kubernetes rolling updates. Here rolling generally means one pod at a time will be updated. So here new application version means new code and the new Docker image. So we are going to change the image now. So for that I have the command kubectl set image for deployment, and the deployment name is nginx hyphen deployment. The next image will be nginx equal to nginx colon. I can give particular version here, for example 1.21. Then I can add hyphen hyphen record flag also. Then I can check the progress also here using kubectl rollout status and the deployment. The deployment is nginx hyphen deployment. So you can see deployment Nginx deployment is successfully rolled out. So when I run the rolled update, this is what happens internally. The first Kubernetes creates a new pods with the updated image. Then the old pods are gradually terminated. And the main thing is this transition ensures the zero downtime. I can check the history of this particular rolled out update also using kubectl rollout history command. Instead of status, I can just give history here. You can see this is the command I have executed earlier. So here by default Kubernetes updates only one pod at a time, but you can customize that using the YAML file. So let's see that now using the deployment YAML file. So here in deployment specification, I can add one content called a strategy. In strategy type is rolling update, and here I can modify the max surge and max unavailable pods. So max surge means maximum extra pods during the update, and max unavailable means maximum unavailable pods during the update. So this I can modify. By default it is 1, I can modify 2, 3, any number of pods. So let's save this now. So rolled update will ensure the smooth transition without the downtime of your application. Then you can roll back this particular update using the command kubectl rollout undo and the deployment slash nginx deployment. So if I execute this particular command now, so this will revert my deployment to the previous version of my deployment. So if something is wrong in your new version of your application, then you can roll back your deployment using the kubectl rollout undo command. So by default undo will go to the previous version. And if you want to roll back your Kubernetes deployment to the particular version, then I can give the revision number also here. Using hyphen hyphen 2 hyphen revision and the revision number 2, 3 or any number. This number will get using the kubectl rollout history command that we have executed earlier. So that's it. Today we have learned about scaling of our deployments. There we have manually scaled first. Then in auto scaling we have learned about HPA and VPA. Then we have learned about rolled updates. Then we checked out about the rollback of our update also. Come on guys, today we are going to learn Kubernetes services. Before starting with the hands-on, why do we need services actually? In the previous session, we deployed application using deployments, then we scaled them, then we perform the rolling updates. Everything is fine, but there is a one big issue. How do these pods communicate with each other? Or how do we communicate to the pods from the outside world? For that, we need Kubernetes services. Even each pods will have its own IP addresses. But pods are ephemeral, means pods can be created or destroyed at any time. So each time when a pod is restarted, it gets a new IP address. So this will make hard for other pods or for the external users to communicate with the pods. So Kubernetes services will provide a stable IP or DNS names. This will expose the application and it will ensure the seamless communication. So let's see that in action now. So I have already created the cluster. Let me create a deployment now. So I have already have the deployment YAML file that is I have used in previous sessions. I've explained this YAML file in previous session and go and check out those videos. So let's create this deployment now. For that I can run kubectl apply -f, then the file name, that is deployment.yaml. Let's enter that now. So deployment is created now. Now if I run kubectl get pods, so here 4 pods are created, but I don't have the IP address of these particular pods now. To get the IP address of the pods, I can just run the same command kubectl get pods. Then I can give a flag called as -o, then void. So here you can see the IP address of each pods now. Now for example, for first pod, the IP address is 192.168.82.67. Now if I delete this particular pod, so command will be kubectl delete pod, then the pod name, that is, if I run this now, now the pod is deleted, but to match the desired state, that is 4 replicas, my deployment will create a new pod now. Let's check the IP address of that particular new pod. The old pod IP is 192.168.82.67. Now if I run again the same command now a new pod is created 65 seconds ago and the IP address of that particular pod is different. So it has a different IP now. So this is why we need services to provide a consistent way to access these particular applications. So there are 4 types of Kubernetes services. The first one is cluster IP. So here cluster IP exposes a service inside the cluster. So cluster IP can be used for internal communication. And the default service type is also cluster IP one. And the second one is node port. This will expose the services externally using static port on each node. The third one is load balancer type. This will use as a cloud provides a load balancer for external access. The fourth one is external name. Here we will map an Kubernetes service to an external domain name. So now let's check out cluster IP first. So here I have already created a deployment, that is nginx deployment. Let's export this deployment using the cluster IP now. For that I can run kubectl expose deployment and the deployment name, that is nginx -deployment, then -port I will use 80 and the target port also Target port also I will mention as 80 only. The type of the service, that is cluster IP. Cluster IP. So there's a typo here instead of a like a semicolon. Now you can see service engines deployment is exposed. And if I run kubectl get services, you can see Nginx deployment service is there and the type is cluster IP. And this service has stable cluster IP now. So this is the cluster IP service. So we can't access this in externally, but any pod inside the cluster can access this particular service using the cluster IP colon 80 port. Now I will just create a temporary pod in this particular cluster. Then from this particular temporary pod, I will check whether my service is accessible or not. So this is just a temporary pod called as curl pod. I'll use this pod to run the curl command. Pod name is curl pod and the image is busybox plus curl image. Then I will run in interactive mode and this is that for terminal. I got some error like bin sh is not found b, and this is because I'm running in Windows, not in Linux. But the curl pod is created now. So in Windows we can just run winpty then the kubectl exec command. Now I have logged into the curl pod now. Now if I run curl then http and the cluster IP, that is this is the cluster IP and colon 80, I'm getting the Nginx default response. This means I am able to access the Nginx pod from this particular curl pod. So pods inside cluster can be communicate with each other using the cluster IP. That is about the cluster IP. Let's check the node pod service now. Let's create a node pod service now using the command kubectl expose deployment. The deployment, that is Nginx deployment name. Then the port, that is 80, and the target port, that is also 80. Then the service type, that is node port. I got an error like Nginx deployment is already exists because cluster IP service is already exist. Either I can delete that cluster IP service or I can just give a new name for this particular service. Hyphen name equal to Nginx hyphen I will give np. Np means node port. Then enter this command. Now you can see in service Nginx np is exposed. Let's run kubectl get services now. I have one more service called as Nginx NP now, and is the type is a node port, and I have node port, that is 31722 is the node port of this particular service. Now I should be able to access this particular Nginx application using this particular node port, but I have to know the external IP of this particular nodes also. To get the external IP of nodes, I can just run the command kubectl get nodes -mo wide. Now here I can see this is the external IP of first node and this is the external IP of the second node. Now let's access this external IP with this particular node port IP in my browser. Let's see whether Nginx will come up or not. So external IP colon the node port. The page is still loading. I got site can't be reached error. This might be because 31722 port is not open in my AWS security group. I have added the security group inbound rule here, 31722 port, and for the anywhere. This is not the best practice. For testing, I have added this particular CAD range now. Let's save this rule. Now let's try the external IP and the port name, that is 31722. Now I am able to access this particular Nginx page. So when we export the Kubernetes deployment using the node port service, I can access my application using the external IP of the node with the 31722, that is the node port. I have one more node here. Let's see, I am able to access the application using this external IP also. Let's check that now. Yes, I'm able to access the Nginx application using my second node external IP also. So that is about the node port service. Let's check the load balancer service. So let's create a load balancer service now. For that, I can run the command kubectl expose deployment. The deployment name, that is Nginx deployment, and the port port, that will be 80, and the target port, that is also 80. Then the type type, that type will be load balancer. I got a same error like Nginx deployment is already exist, so I will give a new name now. Name equal to Nginx LB. LB means load balancer service. So now service Nginx LB is exposed. Now if I run the command kubectl get service, one more service Nginx LB is created and the type is load balancer, and I will get the external IP now. External IP will be this DNS name now. I can use this particular host name to access my load balancer service. So to create this load balancer host name, it might take a couple of minutes. Then you can access this particular host name in your browser host name, and the port will be 80. You can see welcome to Nginx page now. So when I create a load balancer service in my Kubernetes cluster, it will create a load balancer in AWS. For example, if I go to load balancer service here, you can see there is one load balancer is created, and this is the same load balancer. I have used AWS here, but this is similar in Azure or GCP also. That is about the load balancer service type. I'm not able to demonstrate the external name service type, but in external name, you will map your services with the external domain name. And one more thing, every service in Kubernetes will get a DNS name by default. Instead of using IP, we can use that particular DNS name also. Now, if I run NS lookup for the Nginx deployment service in the curl pod, I'll get the default DNS names here. Similarly, I can do the NS lookup for any other services also like Nginx LB. So it also its own DNS here. Similarly for my node port service also. So here you can see the DNS name here. So that's it for today. Today we learned about the importance of Kubernetes services. Then we deep dived into the 4 types of Kubernetes services. Come on guys, let's learn ingress in Kubernetes. So why do we need ingress in Kubernetes? In previous video we learned about different types of services, but each service has its own disadvantage. For example, cluster IP allows only internal communication. Node port exposes a service on a fixed port on each node. Load balancer service assigns an external IP but creates a new load balancer for each service. That is very expensive. And also imagine a scenario where you have multiple services, an API, a front end, and an admin panel. Managing all of them with separate load balancer is not effective and it is not scalable. Instead, we use ingress, which acts like a single entry point for traffic, and it will smartly route into different services. These are the reasons we need ingress. Also, ingress will provide features like path-based routing, host-based routing, and TLS termination, and other features. So let's go to the hands-on part now. In hands-on part, first we have to create an ingress controller. To route the traffic to the services, we need an ingress controller, which manages the ingress rules. We can use the controllers like Nginx ingress controllers, AWS ALB controllers, or any other type of controllers. So let's install the controller first. I'm going to use the Nginx controller now. The deployment YAML file will be there in this particular GitHub path, and I'm directly going to run kubectl apply now. Let's run this now. Now Nginx controller is created. Let's verify the Nginx controller is created or not by running kubectl get pods command. You can see one pod status is running and another two is still it is in completed status. Now let's create two services. One is front-end service, another one is API service. First, let's create a API deployment YAML file, vi API deployment.yaml file. I've added the YAML file content here. I have explained the deployment YAML file in previous session and go and check out previous video for more explanation. Here we have AKMS, API version kind metadata and spec. I'm using HTTP echo image from HashiCorp. When I run this container, I will get a message called as API service and the container port is 5678. Let's save this YAML file now. Let's create the deployment using kubectl apply -f and the file name that is API dep.yaml. The deployment is created now. Let's create the service for API deployment. For that, I can run the command kubectl expose deployment, then the deployment name that is API-deployment. Then the port I'm going to use is 80 and the target port that is nothing but the container port that is 5678. Then the name for the service I can give API-service. Spelling is wrong here, name. Let's run this command now. Now the service is created. If I run kubectl get service, I have the API service now. Also, you can see type is cluster IP because default service is cluster IP service. Let's create the front-end deployment now. VA front-end deployment.yaml. Here also I used the same image and the text will be different now. That is front-end service. And I'm using the same port 5678. Let's save this YAML file now. Let's create the deployment using kubectl apply -f front-end deployment.yaml file. Deployment is created. Let's create a service now. kubectl expose deployment name that is front-end -deployment. Port I will use 80 and the target port that is container port 5678 and the name front-end service. Let's run this now. Service is created and if I run kubectl get service, I have one more service here, front-end service. Now I have two services. Let's create the ingress rule to route the traffic. I'm going to use path-based routing now. I want to route /API traffic to API service and /app traffic to front-end service. Let's create the YAML file vi ingress.yaml. We need AKMS. API version is I'm going to use networking.K8s. Then the kind will be ingress because I'm going to create ingress resource now. The metadata I have given name as my ingress. Now in spec I am going to create rules. Rules will be HTTP rules and I'm going to create a path based routing. That's why I have to give the paths now. First path will be API path. Then I have to add the backend for this path. Backend will be API service. While creating the service, I have used 80 ports, so port will be 80. Then let's give one more path for front-end service. Here path is /shap and path type is prefix, and the backend is another service, that is front-end service, and the service port is here also 80. Let's save this YAML file now. Let's create the ingress using kubectl apply -f ingress.yaml. Ingress is created. Let's run kubectl get ingress. You can see my ingress is created now. Address is not yet available. It will take some time. Let's run this once again now. Still address is empty. Looks like some issue here. Let's delete this ingress now. Let's modify the ingress.yaml file. I think the YAML file is correct only, but I have not defined the class. That is the missing part, I think. I've added the ingress class, that is nginx, so that it will use the nginx controller that I installed earlier. Let's save this YAML file now. Let's apply this now. Ingress is created, but I got some warning here. This one is depreciated. I have to use this now. Let's run kubectl get ingress now. Kubectl get ingress. Now I have the address here. You can ignore the warning I got earlier. Now let's touch this in my browser now using this external address. If I run only the address, I will get 404 not found. If I add /app, I get the message front-end service here. Similarly, if I run API, I get the message API service here. So ingress rule is working perfectly. So that's it for today. We have learned how to use ingress today. Come on guys, let's learn config maps and secrets in Kubernetes today. In any application, we have two kinds of data. One is application data, another one is the configuration data. We have to store this configuration data separately from the application code. For that, we can use config maps and secrets in Kubernetes. To store the sensitive data, you can use secrets, and for other non-sensitive data, you can use config map. Let's see these two in action now. Let's create the config map from the command line. So for that, I can run kubectl create config map. Then the config map name, I can give my config. Then I have to give the config map data. In command line, to give the config data, I can give the from --- from literal. Then I have to give the key value pair. For example, I can give app mode equal to production. So app mode is the key and the production is the value. Then if you want to store one more config data, then you can give same flag called as from literal. Then for example, log level equal to debug. Like this, I can give multiple data here. Let's run this command now. Config data is created now. To get the config map, I can run the command kubectl get config map, then the config map name, then -o, and the format I can give YAML format. So this will give the config map data, like app mode is production, log level is debug. So like this, we can create the config map from the command line. Instead of CLI, we can use the YAML file. Instead of the CLI, we can use the YAML file to define the config map. Let's create a YAML file, pi config map dot YAML. So in the YAML file, I can define API version, that is v1. Then kind is the resource I am going to create. I am going to create config map. So kind is config map. Then in metadata, I can just give a name for this particular config map. Then the actual config map data. I'm going to store two configurations. One is the app mode, that is dev, and log level is error. Let's save this YAML file now. Then I can run kubectl apply -f config map.yaml. So now my config dev is created. If I run kubectl get config map, and the config map name is my config dev, I get all the details here. So my config dev is created now. Then how to use this config map with that pod? For that, I am going to create one more YAML file now. So vi pod config.yaml. So in the YAML file, I can define AKMS, API version is v1, and the kind is I am going to create a pod. Name is provided in the metadata, and in the spec, I am going to define the container. For the container, I am going to use the nginx image. Then the main part, I am going to use the environment variables here. And for the environment, I am going to get the values from the config map data. I'm going to use two environment variables. One is app mode and another one is log level. And for app mode environment variable, I'm going to use app mode config key. And for log level environment variable, I'm going to use the log level config map key. And I'm going to use my config map. So that is the YAML file. Let's save this YAML file now. Let's run kubectl apply now. Kubectl apply -f pod -config. This should create the pod now. If I run kubectl get pods. So this pod is running now. Now let's check the environment variable of this particular pod. For that, I will just run kubectl exec command. Kubectl exec -id. Then the pod name, that is config map -pod. Then I can just run --print env. Then I can just grep this command, grep app mode If I run this now, I have to give the space here actually. I get one more error related to the terminal now. This is because I'm using the Windows. I can just run winpty for that. Let's run this now. I got one more error. So I will just remove hyphen IT because interactive mode is not required. And winpty also I can remove. If I run this now, I get the config map data here. App mode is production. So app mode environment variable is taking the data from the config map. Similarly, I check for the log level. So log level environment variable is also taking the data from the config map only. So this is how we can use the config map with the pod. Let's create the secret now. For that, I can run kubectl create secret. Then the secret type I can give generic. Then the secret name I can give my secret. Then similar to config map, I have to give the key value pair now. So from CLI, I have to give from literal. Then for example, I want to store the DB password. For that, the key will be DB password equal to then the password, for example ABCD. Let's run this command now. So it created a secret, my secret now. Then I can run kubectl get secret and the secret name, that is my secret, and the output format to the YAML file. So I get the DB password, but it will be in the base 64 encoded format because it's the secret and it is the sensitive data. For the verification, I can just decode this particular data also. You can see once I decode the data, I will get the actual password, that is ABCD. Then similar to config map, I can create the secret from the YAML file also. So va secret.yaml. Here API version is v1 and the kind is secret. I am going to create the secret Kubernetes resource, and in metadata I am going to give the name for this particular resource. Then the type of the secret will be opaque here. Then the data is DB password and it will be base 64 encode. Let's save this YAML file now. Then run kubectl apply -f secret.yaml. You will get the warning, but my secret is configured. And if I run this command now, I will get base encoded data here. Now let's use the secrets in the pod. For that, I am going to create the pod with secret YAML file. So in the YAML file, API version is v1 and the kind is pod. The metadata, I am going to give the pod name. Then in the specifications, I'm going to define the containers. I'm going to use the nginx image and I'm going to create an environment variable DB password. And I'm going to get the data from my secret. The key will be DB password. Let's save this YAML file. Now if I run kubectl apply -f and the pod secret.yaml, the pod is created now. And if I run kubectl get pods, secret pod is created and running. Then I can run kubectl exec command to print the environment variable, and I'm going to grab the DB password environment variable. I will get the DB password here, and it is taking the data from my secret. We have mounted the config map and secrets as an environment variable till now. Also, I can map those as files. Mounting as files is nothing but the mounting as volume. Let's mount the config map first. For that, I can create a file cm or config map as volume.yaml. So here instead of environment variable, I'm going to use volume mounts. The name of the volume is config volume and the mount path is the file path. File path is etc config. And in volume, I am going to use the my config config map. Let's save this YAML file now. Let's run kubectl apply now. Kubectl apply -f cm volume.yaml. So one more pod is created now. To verify that, I can run kubectl exec, and in the pod I'm going to cat this particular file path. I'm running this Windows, that's why I'm giving a double slash here. Otherwise you just use the single slash. Let's run this now. So I get the value here. So config map I can mount as the environment variable as well as the files. Similarly, I can mount the secret as volume also. For that, I can create a file first, secret volume.yaml. Here also same, I am going to use the volume mounts and the volume mount name is secret volume, and I'm going to mount the secret to the etc/secret mount path, and I'm going to use this particular secret. Let's save this YAML file now. Then I can run kubectl apply -f secret volume.yaml. So here kubectl. So pod is created now. Now if I exec this particular pod and cat this particular file path, I will get the secret value here. So this is how I can mount the secret as a volume. So that's it. We have learned about the config map and secrets today. We created both config maps and secrets via CLI, then via YAML file, then how to use those with the pods via environment variable as well as mounting as files. Come on guys, today we are going to learn persistent storage, that is PV and PVCs in Kubernetes. So by default, Kubernetes stores the data inside the pod's file system. But we know that pod is ephemeral, means it is temporary. So if a pod restarts, all the data is lost, it's gone. To avoid that in Kubernetes, we have persistent volume and persistent volume claims, PV and PVCs. Here first we can create a PV, then we can create a PVC, then we can mount that PVC to a pod. So let's create a PV first. For that, I can create a YAML file, vi p.yaml. So in the YAML file, as usual, we have AKMS, API version, kind, metadata, and spec. And we are going to create a PV. So kind will be the persistent volume. And I'm going to name this PV as my PV. And in specification, I define the capacity, that is the storage capacity, that is 1 GB. And the access mode is read write once, means allows one node to read write. And the reclaim policy is return, means keep the data after the PVC is deleted also. And the storage class name is manual. And path I'm going to mount is mnt/data. This is the path on the node where the data is stored. Let's save this YAML file now. Let's apply this now using kubectl apply -f pv.yaml. PV is created now. I can get the confirmation by running kubectl get PV. So my PV is created here. So next step is creating the PVC. For that, I'm going to create one more YAML file, vi pvc.yaml. So here also AKMS and the kind will be persistent volume claim, that is PVC. And name of the PVC is my PVC. And in the specification, access mode is read write once. And in the resource, I have the storage 1 GB. And the same storage class name, that is manual. Let's save this YAML file now. Let's apply the PVC using kubectl apply -f and pvc.yaml. So PVC is created now. We can verify that using kubectl get PVC. So my PVC is created here. So next step will be use this PVC in a pod. For that, I am going to create one more YAML file, vi pod pvc.yaml. Here also I am going to use AKMS and the resource is pod. So kind will be the pod and the pod name is PVC pod. And in specification, I am going to declare the volumes. Volume name is storage and I am going to use PVC, persistent volume claim. And the claim name is my PVC name, that is my PVC. And for the pod, I am going to use Nginx container. And for the container, I can define the volume mounts here. And the mount path will be this one. And the name of the volume mount is storage. That's it. Let's save this YAML file now. Let's apply this YAML file, kubectl apply -f pod pvc.yaml. So pod is created now. I can verify that using kubectl get pods, kubectl get pods. PVC pod is created, but it has a one error here. And when I run kubectl describe pod, I'll get these errors here. You can see failed to mkdir mnt/data. So mnt/data folder is not able to create. Maybe manually we can log into those nodes and create these particular folders. I logged into one of the node and I tried to create a data directory inside /mnt. I got the same error here. The issue here is I can't create a directory inside root file system. So here instead of host file, I'm going to use disk provided by the GCP only. So I'm going to create a new disk using gcloud command now. So now the disk is created. I can use this persistent disk now. Let's modify the pv.yaml now. So instead of host file system, I'm going to use a GC persistent disk here. And the PD name, that is persistent disk name, is my PV disk. And the FS type is ext4. Let's save this YAML file now. Let's apply this now. kubectl apply -f p.yaml. I think still previous PV is not deleted. So I'm going to give a different name here, my PV PD. And let's save this YAML file. And if I run kubectl apply again now, so now the new PV is created. Let's modify the pvc.yaml also. Here the storage is 10 GB and let's modify the name of this PVC also, my PVC PD. And let's save this YAML file now. And if I apply this pvc.yaml, new PVC is created now. Let's modify the pod YAML also. Here claim name will be my PVC-PD. Then let's save this YAML file now. Let's apply this YAML file now. Now the pod is created and if I run kubectl get pods, the PVC pod is created and the status is running. So host path mounting is not working. So we created a persistent disk and we attached that. Now let's verify that using kubectl exec to that particular pod and let's run df disk free command. You can see /data is attached now and it is almost 10 GB, that is 9.8 GB. This is /data because in the YAML file we have mentioned as /data. In the pod PVC YAML file, you can see mount path is /data here. That's why it is attached to /data mount path. Let's create a file in that particular path, that is in /data path. For that, I'm going to run kubectl exec and inside the file, I'm going to write persistent data. Let's run this now. For some reason in git bash, it is not working. I am using command prompt for this particular command. Let me run this in command prompt now. So it added the content now. Now let's delete this particular part and let's see whether it's able to persist the data or not. Let's enter this command now. PVC pod is deleted now. Now if I run kubectl get pods, I don't have any pods here. Let's apply the pod YAML again. So it should create one more pod now. If I run kubectl get pods now, kubectl get pods, PVC pod is created now. Now let's verify whether the data is persisted or not by running kubectl exec and the cat this particular file path. If I run this now, I get the same content here. That means data is persisted even after deleted the pod. So that's how we create PV and PVCs and using those PVCs inside the pod. So here instead of manually creating the PVs, we can dynamically provision those PVs. Let's see how this works. For dynamic provisioning, we have to create the storage classes. So let's first see what are the storage classes are available. For that, I can run kubectl get storage class. Here I can use premium ROW, standard and standard ROW. These are the storage classes available in GKE. So let's create a PVC using dynamic provisioning. For that, I can create a YAML file vi dynamic PVC dot YAML. Here in this particular PVC, I'm going to use storage class name as standard -ROW instead of manual. This is GK's default storage class name. Let's save this YAML file now. Before applying the PVC, let me run kubectl get PV. Here I have only one PV, that's my PVPD, and this PVC I manually created earlier. Similarly, if I run kubectl get PVC, I have only one PVC, that is my PVCPD. Now I can apply this particular dynamic PVC YAML file. If I run this, it should dynamically create the PV also. Here I have not created any PV for this manually. So dynamic provision should happen now. Let's run this now. If I run kubectl get PVC now, you can see my dynamic PVC here, and it's the storage class is standard -ROW. You can see it is stuck in pending from last 4 minutes. So I run kubectl describe PVC, my dynamic PVC, and I will get some error message here waiting for first consumer. And if I run kubectl get storage class also, I can see for premium ROW and standard ROW, I can see the message here waiting for first consumer, but standard I can use immediately. So I will use the standard class now instead of standard ROW. Here I will change the storage class to standard, and the name is my dynamic PVC standard. And let me save this YAML file now. And if I run kubectl apply now, it created a PVC now. And if I run kubectl get PVC now, kubectl get PVC, it created my dynamic PVC standard now, and I have the volume here. Now if I run kubectl get PV, I should have two different volumes. One is manually created, another one is dynamically provisioned. Kubectl get PV. You can see this is the first PV that is created manually, and this is the dynamically provisioned PV. The storage class is standard. This is how we can dynamically provision the PV also. So manually creating PV every time is not required. So that is about PV, PVC, and using the PVCs inside your pod. Also, we saw data is persisted even when the pod is deleted. That's how we can use PV and PVC for data persistence. Also, there is no need of manual creating the PV. We can dynamically provision those PVs. Come on, guys. Today we are going to learn stateful sets in Kubernetes. Stateful sets are essential for managing database applications like MySQL, Postgres, or etc. We call these applications as stateful applications. Even when the pod restarts, stateful sets will maintain the stable network identities and the persistent storage. So let's deploy a stateful set now. Before creating the stateful set, we have to create a service. For that, I can create a YAML file, vi stateful set services dot YAML. So this is the service YAML file content. We have AKMS. API version is the v1 and kind is the resource we are going to create in Kubernetes. That is nothing but a service here. And in metadata, I am going to give a name that is MySQL. And interesting thing here is in the specification, we will give cluster IP as none. And this type of service, we call it as headless service. And the headless service is required for the stateful sets. Here for the pods, we don't assign the single IP. Instead of that, we assign the DNS names. That's why we are going to use headless service here. We are going to use MySQL port that is 3306. And the target port also same. Let's save this YAML file now. Let's run kubectl apply now. Kubectl apply -f ss-services.yaml. Service is created now. If I run kubectl get services, I have the MySQL service here and the cluster IP is none and the port is 3306. That is the MySQL port. Now let's create the stateful set. For that, I am going to create a YAML file vi stateful set.yaml. This is the stateful set YAML. We have the API version that is app/v1 and the kind is the resource that I am going to create, that is stateful set. And then the metadata, the name is MySQL, and in the specifications, the service name that I have created earlier, that is MySQL. And the replicas, the number of ports, that is 3. And the label is MySQL. These are similar to previous YAML files. Then the container I am going to use is MySQL container, and the image is MySQL 5.7 version. And I am going to use the environment variables. And the first environment variable is MySQL root password and the value here, and the port is container port, that is again 3306. And the volume mount I am going to use, that's the MySQL storage, that is the name of the volume mount, and the mount path will be varlib MySQL. This is the volume climb templates. I am going to use access mode read write once, and the storage will be 5 GB. Let's save this YAML file now. Let's apply this YAML file using kubectl apply -f and the stateful set YAML file. You can see stateful set MySQL is created now. We can run kubectl get stateful sets I can run kubectl get pods also. Kubectl get pods. The pods are failing with crash loop back off error now. I just check the logs of first pod here. Kubectl logs -f and pod name, that is MySQL 0. And I get the error like the data directory has files in it, so it is not empty. Let's delete those files inside the data directory, and let's see whether this error is resolved or not. Now I have deleted the file. Let's see kubectl get pods now. Now you can see all the three pods are in running state. Here I can check the hostname for each pod by running kubectl exec and the cat8s hostname file. If I run this now, you can see hostname of first pod is MySQL 0. Similarly, for other two pods, MySQL 1 and MySQL 2 are the host names. In case of deployments, each pod will get its own IP, but in stateful set, we will get the host names. And these host names will not change even if we restart the pod. That means stateful set will get the stable network identity. Let's delete one pod and let's see whether the same host name will be there or not. So kubectl delete pod, and the pod I am going to give MySQL 1. MySQL 1 is deleted now. If I run kubectl get pods now, you can see MySQL 1 is recreated now 9 seconds ago. And if I check the hostname for MySQL 1 now, hostname is same even after restarting the pod. Once we deleted MySQL 1 pod, it recreated because in YAML file we mentioned as replicas as 3. Now for example, if I mention replicas as 5, then there will be two more pods with the name MySQL 3 and MySQL 4. I can scale the stateful set using kubectl scale stateful set and then the stateful set name, that is MySQL, and the replicas I have mentioned as 5 now. Let's run this now. Stateful set MySQL is scaled now. Now if I run kubectl get pods, now MySQL 3 and MySQL 4 is created, but it is failing with the crash loop back of error. This is the same issue we have seen earlier on these three pods. This error is because data directory is not empty. To resolve this error, I will create a temporary pod called as debug pod, and I will attach MySQL 3 PVC for that. Then I applied that YAML file, then the debug pod is created now. Then I can log into this debug pod now using kubectl exec. Then I change the directory to mnt and MySQL. And if I run ls here I have one directory, that is lost phone directory. I have to delete this directory because MySQL directory should be empty every time. So rm-rf lost phone directory. Let's exit from this temporary pod. Now if I run kubectl get pods, now both the pods are in same error, crash loop back of error, but I have resolved for MySQL 3. In some time it will come to running status. Let's wait for that. Same thing I can do for MySQL 4 also. I have modified the YAML file now. Here also I can delete that particular lost found directory cd mnt MySQL, and if I do ls here, lost found is there, so rm-rf that particular directory. So here also it is deleted now. Let's see kubectl get pods again. Kubectl get pods. Here you can see MySQL 3 is running now, and sometime MySQL 4 also will be in running state. Let's run kubectl get pods again. Kubectl get pods. Now you can see all the pods are in running status. Now if I check the hostname for MySQL 3, you can say hostname is MySQL 3 here. Similarly for MySQL 4, hostname is MySQL 4 here. So in stateful set, even when we scale the number of pods, we will get the stable network identity. Now let's try the rolling updates with the stateful set. For that, I am going to modify the stateful set YAML file. Here I am going to update the MySQL image. Instead of 5.7, I am going to use 8.0. Let's apply the changes using kubectl apply -f stateful set YAML file. You can see MySQL stateful set is configured now. You can check the rollout status using kubectl rollout status, then the MySQL stateful set. You can see the status here waiting for one pods to be ready. And if I run kubectl get pods, you can see MySQL 0 and MySQL 2 are running, and the MySQL 1 is container creating. And when we run rolling update, it will update only one pod at a time. For example, MySQL 0 will be updated first, then MySQL 1, then MySQL 2. Now you can see all the pods are running state. This is how you can perform the scale and rolling updates in stateful sets. Also, you can delete this stateful set using kubectl delete stateful set and the stateful set name, that is MySQL. You can see MySQL is deleted now. Even after deleting the stateful set, the PVC should still exist. If I run kubectl get PVC, you can see all the PVCs are there here. I can delete all these PVCs at once using kubectl delete PVC, then label app equal to MySQL. So all these pods, all these PVCs should be deleted now. Come on guys, let's learn Helm today. So what is Helm? Like in Linux, we have apt and m, right? apt is for Ubuntu based and M is for CentOS based. These are the package managers, and Helm is the package manager for Kubernetes. So first we have to install the Helm in your system. For that you can just search for Helm installing in documentation in your Google or any browser. You will get this particular documentation. Here you have the steps to install the Helm using the script, or if you are using Mac OS you can use it by brew install Helm, or if you are using Windows you can just install using Chocolate. So I have already installed the Helm. So if I run Helm version, so you can see this is the Helm version. So let's run Helm commands now. First, I'm going to create a Helm chart. For that, I have the command Helm create. Here everything call it as chart. That is nothing but the template YAML files. So I will create Helm create, then name of the chart, that is my chart. Then enter. So it created my chart. If I run ls, I will have the my chart directory now. And if I go inside that directory, if I run ls-la, so here these files and directories are automatically created when I run helm create my chart. Each of these files and folders are used for specific purpose. Let's see what are these files and folders. I will just explain the general structure of helm chart. So here my chart is the chart directory. Inside that first file is helm ignore file. It is .helm ignore. It is a hidden file. So when I add some files in .helm ignore file, those files will be ignored while packaging the chart. It is just like .git ignore file in your Git directory while writing your code. Here if I run cat.helm ignore, you can see these files and file extension will be ignored while packaging the Helm chart. So next file will be the chart.yaml file. It consists of metadata about this particular chart. The metadata can be name, version or description of this Helm chart. And if I run cat chart.yaml, I will get the details like a version v2, name is my chart and description is a Helm chart for Kubernetes. This is the YAML file actually. You should follow the YAML file syntax here. Next file is values.yaml. It will be the very important file in this Helm chart. It generally consists of default configuration of all the values. While deploying application, generally we modify the values.yaml file contents. If I cat values.yaml file, it has all the details like replica count, image, and many more things. Generally, your application's version upgrade, you will modify the Docker image, the version here. And in the charts directory, we will have all the dependencies. If your chart depends on any other charts, you will mention those charts in this charts folder. And in the templates directory, we will have your Kubernetes resource templates. Kubernetes resource is nothing but deployment, service, or ingress. So we'll have the deployment YAML file, service.yaml file, and ingress.yaml file here. So if I change the directory to templates, and if I run ls-la, so these are the files here like deployment YAML and ingress.yaml, service.yaml, and other resource YAML files also there here. And if I cat one of the YAML file, here you can see the content of this deployment.yaml file. It is very different compared to your general Kubernetes deployment YAML. Here it is a template actually. It is not a actual Kubernetes deployment YAML, but it is a Helm template for your Kubernetes deployment. Similarly, we have the separate template for service and ingress. Also, we have the helpers.tpl file. These are the helper templates for reuse actually. And readme file, we can use it for description or any documentation purpose. And if I cat helpers.tpl file, that file consists these content actually. So this is the general structure of your Helm chart. There will be remote chart also. We can add those remote charts also using the command helm repo add and the which repo you want to add and the URL for that particular repo. And then when I run this helm repo add command, you can see this is added for your repositories. And for updating that, you can run helm repo update. You can see successfully got an update from this particular chart repository. Here this Bitnami chart repository consists of several production ready charts actually. I'm going to install the MySQL chart from this particular repository now. For that, I can run the command helm install and the chart name that is MySQL and the repository that is Bitnami / the chart name that is MySQL. Then if I enter this now, so MySQL chart is installed now. To verify that, we have the command called as help list. It will list all the installed charts. You can see this is the chart I have installed, that is MySQL. There is one more chart also that is I have installed earlier. You can run kubectl command to get the resource here. For example, kubectl get pods. You can see MySQL 0 pod is created and it is in running state. Also, you can uninstall the chart using help uninstall and the chart name that is MySQL. Now you can see MySQL is uninstalled now. And if I run helm list again, now MySQL is not there here. And if you want to see the content of that particular Bitnami helm chart, you can just search for Bitnami helm chart and you will get the GitHub repo for that. And if you open that, you can see these are the contents here. And if I open that Bitnami folder, you can see several applications here, Apache or Cassandra. All these applications are available in this particular Helm chart actually. what I have installed is MySQL. If I search for MySQL, you can see this is the MySQL directory. This is the structure of this MySQL chart. We have the helm ignore, then the chart.ml readme, then values schema.json, then values.ml file. And in the templates, we have many YAML files here. And if I open values.ml, here generally we will add the default values. Here you can see the default image will be the 8.4.4 dbn 12r7 MySQL image. And the by default replica count is 1. That's why it created only one pod. Also earlier I told we can override the values of this values.yaml file. Let's see how I can override the values now. For that I can run helm install, then the name, then the repository, that is bitnami /mysql, then --- set replica count is 3. So it will override the values from my values.yaml file. Also one more option to override the values.yaml file is creating your own customized values.yaml in your local. I have copied the same values.yaml, but I am going to modify the values.yaml file here. So replica count is 3 and I am going to save this file. Now I can run the command helm install, then the name, then the repository, that is bitnami /mysql, then -f and the file, that is myvalues.yaml. That is the customized values.yaml file that I have created now. And if I run this now, there is some error. The file name is myvalues.yaml, not hyphen is not there. And if I run this now, MySQL chart is installed now. Here it is not working. If I run kubectl get pods, it is giving only one pod. But generally it should override the values.yaml. But this replica count is not getting the values from values.yaml. I think if I check the stateful set YAML file, you can see this replicas is hard coded to 1. So generally it should get the values from values.yaml. But here it is hard coded actually. Here you can see all of these values we will get it from the values.yaml file. For example, values.primary node selector. All of these values are mentioned in your values.yaml file. So in any templates, you can call the values from the values.yaml file using this syntax. So that's it for today. We have learned Helm chart. Hello guys, today we're going to learn how to create your own custom Helm chart and how to package that chart from the scratch. So for that, first I have to create the chart. For that I have the command helm create and the chart name. I'm going to give my chart as the chart name. Let's run this now. Now my chart is created, and if I run ls and the my chart folder is created, and if I go inside that my chart folder, I have these files. I have explained the Helm chart structure in the previous video. Check out that video too. Here generally we have the file like chart.ml, then the values.ml, and the folders like charts and templates folder. Using this chart, I am going to create a Nginx application now. So for that, first I am going to modify the chart.ml file. So in chart.ml file, I will paste my content. In chart.ml file, generally we will add the metadata of this particular chart. Generally it is used for identification of this chart. So here we are using this chart to deploy the Nginx application, and the type is application. This type of metadata we will add it in the chart.yaml file. Then the next important file is values.yaml file. In values.yaml file, we will define the default configuration values for this chart. Here in this Nginx application, I am going to add the replica count as 1. Then the image I am going to use is the Nginx image, and the tag will be latest. And the pull policy is if not present, means if image is not present, then only pull the image. Then I'm going to deploy this Nginx application as a service, and the service type is node port, and the port I'm going to use 80, and node port is 30,080 port. Then the container port for Nginx is 80 port. Within the templates folder, we have the two files, deployment YAML file and service.yaml file. So let's first check the deployment YAML file. So this deployment YAML file is similar to your Kubernetes deployment file, but this is the template, so we don't add any values directly here. Here this deployment template also has AKMS, API version, kind, metadata, and spec. Here API version is /1, then kind is the Kubernetes resource, that is deployment. In metadata, I'm going to add the deployment name, but here I'm going to take the deployment name from the release name. Here it will take the name dynamically from the release name. And in the specification for the replicas, it will take the values from the values.yaml file dynamically. Similarly for labels also, it will take the values dynamically from the release name. Then in the container name is Nginx, then the image, it will take the image from the values.yaml file dynamically. Here you can see .values.image repository and .values.image.tag. So from the values.yaml file, and if I check here values.yaml file, it will take the values image.repository, that is Nginx, then the image.tag, that is the latest tag. Then the image pull policy is values.image.pull policy. Then for the container port, it will take the value from the container.port from the values.yaml file, that is 80. This is how you define the deployment YAML template. So for everything, it will take the values dynamically from the values.yaml file or the release name or something else. Then I have the service.yaml file template here. Here also I have the AKMS, API version is v1. Then the kind is nothing but Kubernetes resource, that is service. Then for the metadata, it will take the values dynamically from the release name. Then in the specification for the type, we get the values from the values.yaml file. The value will be service.type. Here you can see service.type, that is nothing but node port. Then for the selector, we will get the values from the release name. Then the port is nothing but the service.port. Then the target port is container port, and the node port will be get it from the values.service.node port. That is nothing but here node port, that is 30,080. Now I have all the required files for my Nginx application. Now I can install this particular chart. For that I have the command helm install, then the application name I will give my app, and the chart, that is nothing but my chart. And if I run this now, my chart is created now. Also you can run commands like kubectl get pods. It will list all the pods. In replicas, I have mentioned replica as one. So one pod is created and it is in running state. Now in our cluster, if the 30,080 port is open, then you can access this application in your browser also. I can access this application using the external IP of my node and colon 30,080. That is nothing but the node port I have mentioned in the values.yaml file. And if I run this now, I will get the application, that is the Nginx application. So I have deployed the Nginx application using my custom Helm chart. Then for application, we generally update our application version, right? Here, if you want to deploy your next version of application, generally you update the code, then you create a new image and you use that image in your values.yaml file. You create a new image version, then you add that particular tag here. For example, here I am updating the tag as 1.27.5. So generally in Helm, for the application upgrade, you generally update your values.yaml file only. You don't modify any templates like deployment.yaml or service.yaml. You only modify the values.yaml file values. Once you updated your values.yaml file, then you can run the command helm upgrade. Instead of install, I'm going to run helm upgrade. Then if you run this now the update is deployed now my application will use the new version of Nginx. That's how you handle the application upgrade using the Helm. Then if multiple users are using this Helm chart and if you want to share this chart, then you have to package this chart first. To package, we have the command helm package and the chart name, that is my chart. It will create a package with .tgz extension. Then you can upload this package to any package register. So that's it for today. Today we learned how to create our own custom chart from the scratch, then how to package that. Subscribe and check out other videos too.